Alright, so question number 10 is asking synthesis of epoxide by base treatment of halohydrates is an example of intramolecular of what? Well, so you have, let's say you have a chain here, a hydrocarbon here, and then you have iodine here, and then you have an alkoxide. So once you have alkoxide with a hydrogen next to it, and a hydride here, this is going to attack to this carbon and it's going to leave, right? So you make this epoxide. Basically, you have an alkoxide and then you have an alkyl halide. That's nothing but just a Williamson ether synthesis. So it's an example of intra, within the molecule, right? So question number 10. Question number 11, it's asking us to propose structures for the product here. So on this guy, well, we have a hydrogen bromide here, and this oxygen obviously gonna react with this hydrogen, and the bromide will be a negative charge on it. So once you have this positive charge, you have a bromide, right? And this bromide is gonna react one of these carbons, the one on the right or the one on the left. Which one is easier? Obviously the one on the left is easier to do that, right? So once you react with this bromine, so you're going to get bromine, react with the carbon right there, the one attacked, 1, 2, 3, and the methyl will be, I'm just pointing it down, and I'm going to have the alkoxide, and then this is going to get a hydrogen, right, from water. So you're going to have an alcohol. So you have bromine, this, and OH. That's going to be the product. So if you want to write down the better, so you can do like this. They are all acceptable. Okay, so question number 12. Question number 12, it's asking us the alkoxyamide reaction with the sodium hydride. So well, this is just forming an alcohol, an ether, right? So with an alcohol that provided. So this is going with the Markovnikov rule, which means that the substitution goes with the more substituted carbon. So the more substituted carbon is here. So we're going to attach the alcohol there, right? So we're going to make an ether using the alcohol that is provided. So I'm going to erase this one. I'm trying to erase this line here. I don't know why it's forming. So I have the rank, and then I have CH3 here. And I'm going to react with an alcohol that we are provided, and then we're going to make it an ether. So this is going to be it, right? So we have 3 CH3s on the carbon, alcohol, carbon on the alcohol. So that's going to be it right there. All right, so now number 13, it's asking chloroperoxybenzoic acid, what will happen in this reaction, or what's going to be the reactant for the product is provided here. This is one of the fancy reagents that's used to make epoxides from a double bond, right? So basically you have a double bond here first, and then you make an epoxide with it, right? So what you do is you're going to just write a double bond here, and whatever the substitutions are. Alright, this carbon more, so like this. And then we're going to have a CH3 here. That's going to be the reactant for this reaction. Alright, question 14, we have the chlorination of a double bond. So this double bond will react with this chlorine right there. And then let me show you like this, chlorine and chlorine. And then this is going to open up, so you form a chlorine here. And now once you do that, you're going to react with the water, H2O. It's going to react from the back. And then you're going to form carbon, chlorine, hydrogen, and CH3 here. On the other end, you're going to have OH and hydrogen, and CH3. Okay. So what? So once you react with the base, then you are getting this hydrogen. You are getting this hydrogen here, and then you're going to make an alkoxide here. Then this alkoxide is going to react with this carbon to make this chlorine go away. So this is just a Williamson synthesis, and then you're going to make an epoxide, right? All right. So this is going to be hydrogen here, and this is CH3. And then hydrogen here, and CH3. Okay, that's just making an epoxide on the second step. Let's move on to question number 15. Here we got sodium hydride. As we know that sodium hydride is a very strong base. It's going to react, right? So we have a negative sign here. We have a negative charge. So this is going to react to this carbon here, because this carbon is very polarized because of this ring strain as well as the oxygen, and this is going to open up. So you make this NH2 hydrogen here, and then you have OH on the opposite side, and then you have CH3 here. That is question 15. All right, let's go to the next one. How to go next one? Right here. All right, so let me see. We have over 23 questions in this one. So let's do 16 here. First, once you have sodium hydride, it's going to react with this OH, so you're going to get rid of this hydrogen, and then you're going to make an alkoxide, right? This is the step 1. Step 2, once you have this alkoxide, obviously it's going to react alkyl halides, right? So it's going to react with alkyl halides. So we have an alkyl halide here. So this alkoxide is going to attach to this carbon right there, and the bromine is going to leave, right? So let's write down the structure. So we have the benzene ring here, and then we have oxygen. This is going to be reacting with the carbon right next to the bromine, and you're going to have CH2. This is the carbon right next to the bromine, and then you have CH, a double bond, CH, and CH3. If you want to write down this structure, if you want to write these structures in a better way, this is what you get, right? So oxygen here, 1, 2, 3, double bond, and 4. We are getting here Claisen rearrangement mechanism. So this double bond here is going to go right there, and this double bond is going to go there, and then you're going to make an oxygen double bond right there, which will then be converted to alcohol in the reaction pathway, and then you are getting this, right? With single bond, you have the methyl here. This one is the one you had as a single bond, and then this is the one you just formed a double bond. That's what we're getting. So in this reaction, we have bromine here, alkyl halide, and then we have a thiourea, right? So once you have a thiourea, you think that this is going to be a formation of alkyl thiols, okay? So this is going to make an alkyl thiol. So this sulfur is going to react the carbon right there, and then this bromine is going to leave. So, and then once you have this alkyl thiol, it's going to react with the base, and then you're going to form a thiol. So basically, you're going to replace the bromine with a thiol, all right? And this is going to be an inversion in the stoichemistry here. So you're going to have a hydrogen here, but on this guy, you're going to get a SH thiol. Alright? Alright, here we have sulfide, and with the reaction of peroxide, hydrogen peroxide. So we know that sulfides are easily oxidized with peroxide, hydrogen peroxide, to give a sulfoxide. So we are going to make a sulfoxide here, right? CH3. This is the sulfoxide we form. Alright, question 19. This question is nothing but just epoxide opening. So you're going to react with an acid, hydrogen iodide. So this is going to be protonated here. So once you protonate this oxygen, is going to be a positive charge, and then this iodine is going to attack from the back, and it's going to open it up, right? This is what you're getting. So this is going to be just hydrogen iodide. Alright, so here we have an alkoxide ion here, and then we have a methyl halide. This is just nothing but a Williamson synthesis. We have done this question in the classroom already. So this is what we are getting, right? Alright, and then question 21. Question 21 is talking about, we have a reactant here. We have a reactant, and then it's reacting with hydrogen iodide, and then we are forming an alcohol and an alkyl halide. Well, what do you have here? What kind of structure here we can have and react with hydrogen iodide to get an alcohol and iodide? This is just a backward Williamson synthesis, right? So we should have an ether here, right? So, but this ether should be in a way that we're going to get most substituted isopropyl on one side, and then we're going to have on this ethyl on the other side, right? So we have an ether, this is ethyl, and this is isopropyl. So once you react with this hydrogen iodide, it's going to protonate here, and it's going to break it apart, so you're getting these two structures. Alright, so this is question 21. That's an easy one, right? So let's do question 22. In this question, we have the epoxide opening, ring opening here. So when I look at the structure, I just see this hydroxide addition here, right? So basically, we are going to be treating this epoxide with an acid. It's going to open up to this structure. Alright, so let's go to the last question here. On the last question, we have an alcohol, right? So we have an alcohol here. Let me draw the structure here. This is a tertiary alcohol. So CH3, CH3, and CH3. We have a sodium hydride here. It's going to get rid of this hydrogen. So we're going to have an alkoxide, negative charge. And this alkoxide will need to be treated something that we can get this product. Obviously, this is a Williamson synthesis, right? So we want to have reaction with something. So this is what I have, right? And this alkoxide will react to this alkyl chain here with a halide on it. So let me draw like CH3, CH2, and CH3. Okay, so we will have this structure with a iodide or bromide here, so we can react with this alkoxide, so we can have the Williamson synthesis, and it's going to give us the product that we want. Alright, so this is going to be it. Alright, that's all what we have for question chapter 18. So I'll see you in chapter 19 on Monday. Have a wonderful weekend.